Welcome to another video of product design and development course. In this video, I'll talk about product architecture. In part one, I'll talk about product architecture definition, some key terms, some of the factors influencing the architecture, and also the two main types of architecture, which is modular and integral architecture. In part two of this lecture, I'll talk about how to establish product architecture for your product. This lecture will use some examples from a case study from Hewlett-Packard printers for mainly for home offices. I have a picture of three models here: an office model, photo model, and then printer and a scanner combo. Hewlett-Packard's home printing division needed to expand product variety while cutting manufacturing costs. Inkjet technology helped consumers and the small office markets by providing high quality, affordable printing. But then as the competition grew, success of these products depended on tailoring printers to specific market demands while continuously reducing production expenses. So that was the need for kind of introducing new models and redesigning this product. This would be a platform product, means there are series of different products that they work around established technological platform. We'll start by kind of defining product architecture and then going into more details of some of the terms that I have underlined here. Product architecture is assigning functional elements to the physical building blocks of the product. It's in a scheme where functional elements are arranged into different physical chunks, and the interaction between the chunks is what defines architecture. We've talked about function, form, performance, behavior, all of that in a prior lecture when we talked about function diagrams. But we'll define some of these terms that I've highlighted here now and talk about what they mean. So again, the first one is product architecture, which is you arranging functional elements into physical chunks. Functional elements are individual operations and transformations that contribute to the overall performance of the product. Remember, performance is the measure between behavior and function. Function is what you desire, what you want out of the system. Behavior is what the system actually does, and the difference between the two would be the performance. Physical elements or forms are parts, components, sub-assemblies that ultimately enable the function. As a designer, you design forms, and how well you design it will determine how well the function is performed or fulfilled, and that means how well the part or the product is performing. So they're all tied together. So now, once you've organized these forms into several major physical building blocks, those are called chunks. So the collection of some components that collectively fulfill certain functions, that is called chunks and known as chunks. Looking at when to expect the product architecture to kind of start being defined and shaping up is this is start taking shape during concept development throughout sketches, function diagrams, and possibly if you make any prototypes at that stage. Whether it's fully defined at this stage depends on the maturity of the core technology. For incremental improvement, architecture is usually set early since the fundamental technology is already established. The focus then shifts to refining the design while production and product variety considerations become more important throughout the design. So when it comes to product variation, architecture plays a key role in the efficiency of that product variation. For an entirely new product, concept development focuses on defining core working principles and technology. And in these cases, product architecture is redefined later during the system level design phase. So it's a little bit different whether you're working on a platform product, which is the case study here, or product variation, or whether you're dealing with a brand new technology. Another point that I would like to remind everyone is something we talked about before, which is the definition of a product. We talked about the 4 C's: configuration, connected, components, and constraints. And you pretty much design a product, design some components that they need to be connected with each other, and how you put them together and how you connect them together will form the configuration of the product. And all of this is based on some constraints that you have. It's based on some of your engineering specifications, but also some spatial constraints that you might have. We'll talk about this again in product development phase a little bit more. So now that we know these 4 C's: configuration, connected, components, and constraints, we'll talk about a little bit of two major architecture types. So again, kind of reminding everyone as definition of architecture, and how you allocate or rearrange functions and assign them to physical building blocks or chunks. How functions are fulfilled throughout your chunks and your physical element. You for the components that you develop, you figure out the location and orientation of those components, and that kind of figure out the architecture and how they go together. And an example here is a great example of 2 different architectures. As you can see, 2 different arrangement of physical building blocks, physical chunks, but same components. So they're the same components, but by arranging them differently, you can achieve 2 different functions out of this system. One of them would be a rear wheel design or a system, and then the other one would be front wheel drive. Again, same components, same functions, but just a different architecture and overall kind of different function of the system. The 2 major types of architecture that we would like to talk about, one is modular architecture, and the other one is integral architecture. In the modular architecture, each module, which is a system or an assembly that loosely coupled to the rest of the system, that each module fulfills a single function or maybe few small functions. A good example here is mentioned here, a bicycle brake and shift control system. The picture on the left, that's a modular architecture. Again, it has module. Brake has its own module. Gear shift has its own module. And they're kind of loosely coupled with each other, but each of them has their own independent function and doesn't affect the other one. On the right image here, this is a same functions, but kind of an integral architecture. The functions of the brake and gear shift are blurred together, and they're combined together. So modular architecture has some unique features. As we mentioned, chunks implement one or maybe few functions, and interaction between chunks are well defined and very clear. As an example here in modular architecture of bicycle brake, you can see. And the advantage of choosing a modular architecture is that it's simple, and a lot of components are reusable. And this is good when you have product variety, a lot of product variety, or you're working on platform products. Another good example of it is Swatch watches. They use a lot of similar design components across variety of different models. So these are good example of it. On the other hand, we have integral architecture. So you will have fewer parts, but as a result, those parts they fulfill the same function. They don't have their individually fulfilling functions. All the functions are kind of blurred together, and each module in this case will fulfill several functions. Some of the features of integral architecture is functional elements are again implemented by multiple chunks, or chunks may implement many functions or multiple functions. Interactions between chunks are poorly defined, and it's not because the team can't define it. It's because of the nature of integral architecture. The interfaces and interactions are not clear, are not very distinct. Integral architecture also depends on the product, but generally increases the performance and reduces cost, because sometimes the parts are number of parts are reduced, and therefore the costs are reduced. Here's an example: a BMW motorcycle. It uses what is function sharing, means again same chunk fulfills multiple functions. And integral architecture has implemented in this design. The chassis and transmission and support are all kind of blurred together, and they all fulfill that function. Here's another example from Boeing: blended wing body aircraft. Again, typically, in traditional aircraft, wings usually fulfill the function of generating lift, fuselage, storing passenger and cargo, tail, controlling pitch and yaw, versus this one, this BWB aircraft, all the functions of wing, fuselage, they're all kind of blended together. Here's another example. The same product, a trailer, kind of a pullback trailer. One is a modular architecture, one has an integral architecture. So on one side you see the components or chunks, I should say chunks or components here, groups of components, and the other one you see their function. On the modular architecture, each chunks fulfill one function. Very simple relation. When you look at the integral, each chunk might fulfill several functions, or on the other hand, several functions might be fulfilled by one chunks. So it works both ways. The wheels are still doing the same function as before, so that has stayed unchanged. Here's a good example that we can look at. I'll give you few seconds to think about what this device could be, and whether you think it's a modular or integral architecture. So let's think about it for 5 seconds. All right. I don't know what your guesses were, but this is a nail clipper. So that's a modular architecture versus an integrated architecture that we typically have in this product. And you can kind of see how deciding which architecture to go with totally can affect how a product might be used or looks like. So speaking of decisions that you have to make, let's look at some of the implications of that decision that you make and some of the factors that you have to consider in your decision. The first one is the product change, and architecture can define how the product can be changed later. In modular architecture, you change few isolated elements of the product, versus integral architecture, any changes will influence many functional elements and requires changes to several chunks. There are some factors that you have to consider as part of the product change and this decision. Whether your product needs to be upgraded. For example, changing a processor board in a computer printer or replacing a pump in a cooling system. Another factor is, does your product need some add-ons? Many products are sold by manufacturers as basic unit, and then the user can add components, sometimes even produced by third parties. Another factor to consider is adaptation. Some long-lived products may be used in several different environments. For example, machine tools may need to be converted from 220 volt to 110 volt power. Another factor is wear and tear and replacement parts. So consider what is happening with wear and tear. A good example of it is a lot of razors. You can replace the blades or tires on a vehicle that are replaced. Those are part of wear and tear. Another thing is what material does your product consume? An example of it would be a cartridge in a printer. That's a consumable, and how that needs to be changed. Or when you older cameras, when you put a film cartridge in a camera, or you put glue in a glue gun, glue stick in a glue gun, and so on. Another thing is how flexible your product can be for the user. For example, when you sell a camera, the user can use different lens, different flash settings, a lot of different remote controls that will go with that product, and they can use it with. And finally, another factor to consider is how reusable your product is going to be. For example, in consumer electronic, you may wish to update a product line by changing only some user interface, an enclosure, when most of the inner working previous models will remain the same. So those are some factors to consider for deciding between modular versus modular versus integral architecture. Number two, thing that will decide a factor to affect your decision would be product variety. Variety refers to range of product models that your company can produce within a particular time period in response to market demand. Products built around modular product architectures, products that are built around modular architectures can be more easily varied without adding tremendous complexity to the manufacturing system. Next factor affecting the decision would be component standardization. That means use of the same components or chunks in multiple products. If a chunk implements only one or few widely used functional elements, then the chunk can be standardized and used in several different products. That standardization allows for the company to manufacture the chunk in higher volumes, and as a result lower the cost of manufacturing. Next, you got to consider product performance. And performance is how well a product implements its intended function. The difference between behavior and function is performance. And in an integral architecture, the redundancy could be eliminated through function sharing, as the case of BMW motorcycle example that we saw. And allows for geometric nesting of components and this minimizes the volume that the product occupies, and overall, enhances the performance of the product. This function sharing and nesting kind of allows use of material also to be minimized, and potentially reducing the cost of manufacturing the product, which brings us to the next one, which is manufacturability. The product architecture directly affects the ability of the team to design a chunk to be produced at low cost. One important design for manufacturing, or DFM strategy, which we'll talk about in future videos, involves minimizing the number of parts in a product through component integration. Because the product architecture constrains subsequent detailed design decisions. In this way, the team must consider the manufacturing implications of the architectural decisions they make. And lastly, the product management style could be totally different for modular versus integral architecture. Modular approaches require very careful planning during system level design phase, but detailed design is largely concerned with ensuring that the team assigned to chunks are meeting the performance, cost, the schedule requirements, and stuff like that. In an integral architecture, it requires less planning and specification during system level design, but it requires substantially more integration, conflict resolution, and coordination during detailed design phase of the project. So these six are some of the factors to consider before deciding on modular versus integral architecture. In part 2 of this video, I'll go over the steps involving establishing a product architecture. Thank you.